So hello students, today we are going to cover projectile motion that is to be asked in your exam for specifically for Andhra Pradesh Industry Promotion Officer. So first of all I would like to say that this opportunity, it is a very good opportunity for all of you because there are 95 seats and all the streams are eligible for it, and there is ample amount of time because detailed notification it will be out by 15th of August. So lump sum there are 2 months for it. So and after that there will be time for exam. So you have ample amount of time to prepare for it. So you should join it. A dedicated batch is already going on at ECP. So you should prepare for it. Okay. So let's start with projectile motion. Our today's topic is projectile motion. See, in projectile motion, in your syllabus, there are two topics. The first topic is horizontal and oblique projectiles, and in that we have to cover maximum height, time of flight and range. Okay. So one by one we will take up all these topics. So first of all, talking about the projectile motion, see, projectile motion, it is motion in a plane. It is motion in a plane. Let me explain. Let's say this is the ground, this is the ground, and let's say I throw a body at a velocity v. I throw a body at velocity v at a certain angle theta. At a certain angle theta. Now, what will be the path or trajectory of this body? See, it will go like this. It will go like this. And somewhere here, it will land. So, for the time it stayed in air, for the time this body, it stayed in air, that is your time of flight. That is your time of flight. That is T. Now, the horizontal distance or horizontal displacement, you can say this horizontal displacement, that body started its journey from here and it landed here. The horizontal displacement is called your range. It is called the range of the body, and during its journey from this point to this point, in between it was at a maximum height. It was as a maximum height, and this is called your H max or maximum height. So one by one we will cover these three. Range, this is your range, this is your maximum height, and the time is time of flight. Okay. So first of all, let's talk about oblique projectile. See, what is oblique projectile? When a body, it is thrown at some angle. When a body, it is thrown at some angle theta, and its path is like this. Okay, let me make a bigger diagram. From this point, a body is projected at a velocity v at some angle theta. Now, talking of vector resolution, we can say since velocity, this is a vector, it will have two components. It should have two components. One component will be along this and other will be like this. So this component is your v sine theta and this component is v cos theta. Now, the body, it will cover like this. its trajectory will be like this. Okay. See, now let me divide this trajectory or this whole path into number of points. This is, let's say, point 1, this is point 2, and this is point 3, and this is point 4, and this is, say, point 5. See, when a body is moving through 1, 2, 3 and all these n number of points, what will remain constant? What will remain constant? See, this horizontal component v cos theta, it will remain constant throughout the journey. It is v cos theta here, here it will be v cos theta. Even at the top or the highest point, it is v cos theta, and here at 4 it is v cos theta, and 5 as well, it is v cos theta. Now, why is velocity not changing in the x-axis? Because there is no acceleration in the x direction. There is no acceleration in the x direction. The only acceleration that will act on the body during flight is acceleration due to gravity. And we know acceleration due to gravity, it is towards the center of Earth. Okay. So G, only G acceleration, that is acceleration due to gravity, it will be there. So which velocity now you can think of will change? The velocity that is in the direction of acceleration, that is vertical velocity. Now let's say at this point there is some vertical velocity. As we will keep moving toward the highest point, this velocity, it will keep on decreasing, and at the highest point, at point 3, it will become 0. At the highest point in projectile motion, at highest point in projectile motion, vertical velocity, see, there is velocity. The velocity at highest point is v cos theta, but there is no vertical component of it. There is no vertical component of velocity at highest point in the projectile motion. Vertical velocity is 0. Very important. Okay. Now here, see, the magnitude of the vertical velocity component, it was decreasing, and here it is 0. Now as we will move downward, as I will move from 3 to this point at the ground, the velocity, it will again increase. The vertical velocity, here it is this, at 5 it will be more. Okay, like this. Okay, so as I was moving toward the highest point, my vertical component, it kept on decreasing, and at topmost point it became 0, and at the topmost point it became 0, and as I moved further from top to the bottom, my vertical component, that is this component, it will kept on increasing. Okay, so this is all you need to know for now. Now let's cover the topics. First is time of flight. Time of flight, that is T. Okay. See, we covered see, when I went from this point to this point, I went from here to here. So can you tell me what is the vertical displacement of the body? What is vertical displacement of body? I started my journey from here and I landed at the same level, So I can say the displacement or the shortest distance between the starting point and the ending point, it is 0. It is 0 because these 2 points, they lie at the same level. So vertical displacement, let's say Sy, it is 0. Okay. Now I know second equation of motion, it says that Sy is equal to Uyt plus half of Ay into T square. See, why I am writing this y? Because while applying the equations of motion, all the vectors, displacement, velocity, acceleration, they have to be in same direction. They have to be in same direction. Now if I am talking about the vertical displacement between initial and final point, so I will talk about velocity in the vertical sense as well, acceleration in the vertical direction as well, that is y direction. So now we know Sy, it is 0, and what is initial velocity in y axis? Here the initial velocity, it was v sine theta. It is v sine theta. We just now discussed it here. It was v sine theta. This is your Uy, or initial velocity in the y axis. Okay. So you will say 0 is equal to v sine theta into t plus half of, now acceleration y, it is how much? It is g into t square. Okay. Now one more thing, see, if I am taking the g that is in the downward direction as positive, then I have to take the other vector in the upward direction, that is v sine theta, as negative. Okay. So if I take this v sine theta negative, a negative sign will be added here. Okay. Now if I rearrange this equation, I will get v sine theta into t, it is equal to what? Half of g into t square. G into t square. Cancel t to 1t. You will be left with, see, this is t is time of flight. So it is v sine theta, 2 will go here, 2v sine theta, g will come down, 2v sine theta by g. This is the equation for time of flight. This is your time of flight. Okay. Or you can say this is the time for which the body remains in air. Okay. Now let's move to the next topic, that is maximum height. Second is your maximum height. During the journey, this point, let's say some point x, this was the point of maximum height. This was your h max. Okay. So now if I talk about this point A and this point x, between A and x, what is the vertical displacement? This is the initial point and this is the final point. So vertical displacement is nothing but h max. Between this point and this point, the vertical displacement is h max. Okay. So I can say between A and x, what is the value of now Sy? Earlier in time of flight, we were talking about A point to this point. Let's say this was point B. Now A and B were on the same level, so Sy was 0. So Sy was 0, but now I am going only from A to x. So here my vertical displacement, it is h max. Okay. Now at the topmost point, I know what is 0. The vertical component of velocity is 0. At the topmost point, the vertical component of velocity is 0. And here it was v sine theta. here it is 0, no vertical component of velocity. So if I'm going from A to X, this is my initial velocity in the y direction, v sin theta, and here my final velocity in the y direction is 0. Okay, so I can say u final, sorry, this is u initial in the y direction, it is how much, v sin theta, and velocity final in the y direction, it is 0. It is 0 here. Now use the third equation. I can say vy square minus uy square is equal to 2ay into sy, because it is v square minus u square into is equal to 2as. Okay, it is equal to 2as. Now what is vy? Vy we saw it was 0, so this term is 0. Okay, and what is uy? Uy is nothing but v sin theta. Now see, I told you, if I am taking g acting downward as positive, I have to take any vector acting upward as negative. So v sin theta, it is taken as negative. It is minus v sin theta whole square is equal to 2 into acceleration in y-axis, it is g. Now talking about the displacement in y-axis, see, this is my initial point and this is my final point. So I can say if this is initial, this is final, my displacement along the y-axis, this is h max, it is in the upward direction. I am going from this to this, I am going from this to this. Okay, so my net vertical displacement, it is in this sense, upward sense, and it is equal to minus of h max. Here it will be minus of h max. Now in place of sy, I will put minus of h max. Okay, so what I am getting, cancel this minus to minus here, I will get v square sin square theta by 2g, bring this 2g down, this is equal to h max. So basically this formula is your formula for maximum height or h max. Okay, clear? Now if we are done with h max, now we can cover or we can talk about range. See, range is very easy now. Range, third topic is range. Range was what? It was the horizontal displacement, that is I went from A to B and this is my horizontal displacement and this is called range. Okay, see, I know the time of flight. What was the time of flight? And just now I calculated it. See here, it was 2v sin theta by g. It was how much? It was 2v sin theta by g. So if I put it here, time is equal to 2v sin theta by g. Now I know the time it took from going from A to B. I know the time it took from going from A to B point, that is this much, 2v sin theta by g. And I know the velocity in this direction, in the x direction only. I am talking about the velocity in the x direction only. What is the velocity here? It was v cos theta. It is v cos theta. Now I know if this is my distance AB, if this AB is my distance, then distance is equal to what? It is speed into time. It is speed into time. Now if I am talking about the horizontal displacement, I will only talk about the horizontal velocity component, that is my v cos theta. It is equal to v cos theta into the time of flight, that is 2v sine theta by g, 2v sine theta by g. Now it is equal to what? V into v, it is v square into 2 into cos theta sine theta by g. Now we know what is 2 cos theta sine theta, it is equal to sine of 2 theta. 2 cos theta sine theta is equal to sine 2 theta. So I can rewrite this as v square sine of 2 theta by g. This is my range. This is my range. Okay. So we have seen time of flight, we have seen maximum height, and we have seen range. Okay. So now we know the formula of range. Now we can do a few questions. We know range is equal to v square sine of 2 theta by g. This is the equation. Now let's talk about maximum range. Now let's talk about maximum range. That is my horizontal displacement. I want this to be maximum. I want this to be maximum. For that, what should be my value of theta? What should be the value of theta? See, I know if range is v square sine 2 theta by g, and if I am firing the projectile at a velocity v, so I am keeping v as constant, g is constant, the only thing that I can vary is theta. So to keep this value maximum, this sine 2 theta, this value, it should be maximum as well. This sine 2 theta should be maximum. So what is the maximum value of sine 2 theta? See, for sine A, let's say any angle, the maximum value possible is 1. Maximum value possible is 1. And for that, A has to be 90 degree, because sine 90 is 1. So the maximum value of sine 2 theta is 1. So that means 2 theta, it should be equal to 90 degree. 2 theta should be equal to 90 degrees. So theta should be what? Theta is 45 degrees. This is very important. Has been asked so many times in your exam. This is, make a note, for maximum range, the theta should be 45 degree. For maximum range, your theta should be 45 degrees. Okay. So let me write all the formulas one by one. The first is time of flight. That is t. It is equal to what? It is 2v sine theta by g. 2v sine theta by g. Second is maximum height. It was equal to what? H max v square sine 2 theta by g. Sorry, it was v square sine square theta by 2g. And the last one was your range. The formula for range was 2v square sine of 2 theta by g. Okay, this one is the most important one. And for R max, theta is 45 degrees. Okay. These are the three formulas that should remember. And one more thing about range. Let's say I fired a projectile at an angle of 30 degree. It covered a distance of this much. Now, if I fire this projectile at same velocity but at an angle of 60 degrees now, at an angle of 60 degree now, what will be the range? It will be same. So I can say for complementary angles, the range is same. For complementary angles, range is same. Now what are complementary angles? The angles whose sum is 90 degree. Here the angle sum, that is 30 plus 60, it is 90. So I can say for complementary angles, the range is same. Okay, the range is same. Okay, you can prove this, but no need to do it. Just remember. So if I say I fire a projectile at 10 degree and if I fire a projectile at 80 degrees, the range will be same. Okay, the range will be same in both the cases. Now we have covered time of flight, we have covered the maximum height, and we have covered the range of projectile. Now let's talk about horizontal projectiles. Horizontal projectiles. Now what is a horizontal projectile? When, let's say, this is a tall building, and from the top of it I fired a projectile in the horizontal direction, with a velocity u. Now it will move like this. Up to here. Now at the top of this building, the vertical velocity component, it is zero. It is zero because I am only firing this projectile in the horizontal direction. So I am firing this in the horizontal direction. So there will be no vertical component. So at each of these instants, the horizontal velocity, it will remain same. It will be same at all the points. There are infinite number of points in this path. At all these points, the horizontal component will be same because there is no acceleration along the x-axis. There is no acceleration along the x-axis. So if there is no acceleration, the velocity will not change, or velocity will remain same. Okay. So in this case, this is your H max. This is your H max, because if I am firing it like this, there is a no chance that it will go upward. So this is the maximum height of the object. Now the things we need to find here are time of flight and the range. This is the range now, and time of flight. Okay. First of all, let's talk about time of flight. Time of flight. Now, if I talk about the vertical displacement, so this was the initial point and this is the final position. So I can say my net vertical displacement, it is nothing but H max. Earlier I was at this level, now I am at this level. Okay, I am at this level. So my net vertical displacement is H max. Sy is H max. Now my direction of displacement, because initial point is upward and final point is down, so the direction of displacement, it is downward, or I can say downward I am taking it as positive. If G is positive downward, displacement downward will be positive as well. Now at this point, what is the initial velocity in y-axis? What is the initial velocity in y-axis? It is 0, because I am only giving it horizontal velocity. So I can say uy, it is 0. Okay, and acceleration ay, it is equal to g. Now using the second equation that says Sy is equal to uyt plus half of ayt square. Sy is equal to H max, it is equal to uy, it is 0, this term is 0, half of is equal to half of ay, it is g, into t square. Here t is my time of flight. Now I can say that 2 into H max by g is equal to t square, or I can say t is equal to under root of 2 into H max by g. 2 into H max by g. Okay, so this is your time of flight. Okay. Now we know the time of flight, that is t. Now let's find range. See, range is nothing but my displacement in the x direction. This is displacement in the x direction, this is range. So now if I know the time of flight, it is equal to under root of 2 into H max by g, and I know the velocity in x-axis, it is how much? U. This is my horizontal component of velocity, it is U at all these points. So I can say the distance or range in this case will be what? It is U into T, or U into under root of 2 into H max by G. So we got a formula for range as well. Range R, it is equal to U into under root of 2H max by G. Do remember, this formula is only applicable for horizontal projectile. Only applicable for horizontal projectile. The body only has horizontal component of velocity, as horizontal component of velocity. Okay. So yeah, this sums up our the topics that were asked, that we were required to do. Okay. Now let's cover two questions that have been asked in your exam. Okay. These are previous year IQ exam questions. The first question is, what is value of theta for maximum range? We covered it just now. The value of theta for maximum range is 45 degrees. This was the first question. The second question is, at topmost point, which physical quantity is 0? You can answer this by looking at this diagram. At the highest point, what is 0? The vertical velocity component. The vertical velocity component, it is 0 at the highest point. Okay. Okay. At the topmost point, which physical quantity, let me write this completely, which physical quantity is 0? It is vertical component of velocity, that is 0. That is 0. Okay. So pretty straightforward questions from the class. Okay guys, so in this video we have covered all the topics that you need to cover from projectile motion. Okay, thank you.